In this video series, I work through a math problem or problems each video. Some equations contain two variables x and y in such a way that all of its x and y terms are linear. For example, 2x plus y equals 7 is such an equation. In these equations, x and y can take on any real number values so long as our choices for x and y make the equation true. We can then imagine choosing a number for x and then solving for y. Then these x and y values will satisfy the given equation. Since we can carry out this process for any real number x we choose, there are infinitely many pairs of x and y values that will satisfy the given equation. Note, however, that for any choice of x, there is exactly one corresponding y value, with special exceptions which we'll discuss in the next video. We can take these xy pairs and write them inside a set of parentheses, x value first, followed by the y value, 1, 5, for example. These look like coordinates, and in fact, we can treat them as such. Written this way, we get infinitely many coordinates whose x and y pairs satisfy the given equation. We can then plot all of these points in a coordinate plane. When we do, we find that all the plotted points lie on a single line. In practice, we usually make a table of xy values for a select few points. We plot these points, then connect the dots in a straight line to come up with the graph for the given equation. Let's take a look at the example. Make a table with points from the equation y minus 3x equals 1. Plot the points, then connect them to come up with the graph representing the given equation. So let's start with the equation y minus 3x equals to 1. It's easier to go through these calculations if we solve these equations for a single variable. So let's solve this equation for y. We get y equals 3x plus 1. So to make this table, we want x and y values, so I'll label the first column x and the second column y. Let's choose for the x values minus 3, minus 2, minus 1, 0, 1, 2, and 3. They're relatively small numbers, so they're easy to calculate, and they're evenly spaced, so we will be able to see what's going on when we plot these points. When we plug in x equals minus 3, we get 3 times minus 3 is minus 9, plus 1 is minus 8. When x equals minus 2, 3 times minus 2 is minus 6, plus 1 is minus 5. When x equals minus 1, 3 times minus 1 is minus 3, plus 1 is minus 2. When x equals 0, 3 times 0 is 0, plus 1 is 1. When x equals 1, 3 times 1 is 3, plus 1 is 4. When x equals 2, 3 times 2 is 6, and 6 plus 1 is 7. When x equals 3, 3 times 3 is 9, and 9 plus 1 is 10. So now we have 7 pairs of x and y values that we can use to plot on this coordinate plane. The first point is minus 3, minus 8. The next point is minus 2, minus 5. The next point is minus 1, minus 2. The next point is 0, 1. Then we have 1, 4. Then 2, 7. and 310. Once we plot these points, we can connect the dots to come up with a line for this equation. So this is the equation. This is the graph for the equation y minus 3x equals 1, and we usually place arrows at the ends of these line segments to show that the line extends in both directions.